This is section 5.4, and what we're going to do is talk about permutations. Now, permutation means arrangement. And what we're going to do is we're going to take a set of objects and put them into a particular order, some or all of those objects. Here's an example. Suppose that there are, say, 7 people, and you want to arrange, say, 4 of them, arrange 4 into a row. So the question is, how many ways could we arrange those 4 people out of those 7? You might think that this way. Here's person 1, 2, 3, 4, right? As you look left to right, you see the person on the left, then the second, then the third, and then the person on the right. So out of the 7 people, what we want to do is take 4 of them and put them into an arrangement. So we could have like person A, B, C, D, or B, C, D, F, or B, A, D, C, something like that. Well, this is an application of the multiplication principle. How many choices do you have for that leftmost position? You've got 7 people, so we could put any one of those 7 people here. Then how many choices do you have for this position here? Well, you've taken one person, put them here already, so there's only 6 people left to choose from, so there's 6 choices here. And then for here, out of those 7, you've already put 2 here, so there's only 5 left. And then 4 here. Now this is fine, except I can do better. I can make a little formula out of this. I'm going to take that 7 times 6 times 5 times 4, and I'm going to turn it into a factorial. If I take this all the way down to 1, right, 3, 2, 1, well, I'm really doing what? I'm taking what I want here and multiplying it by 3 times 2 times 1. So to keep this thing balanced, what I'm going to do is divide it by 3, 2, 1. Now look at the top here. The top is 7, 6, 5, 4, 3, 2, 1, all the way down to 1. That's 7 factorial. The bottom is 3 factorial. Now what I would like to do is rewrite this using the numbers that I'm given in my counting problem. I started out with 7 total objects and I arranged 4 of them. Now, in my formula here, I can see the 7, right? I can see the total number I started with. So there's the 7 factorial. Now the denominator is this 3 factorial, and where did that come from? Well, that came from up here when we multiplied by 3, 2, 1. So I got the 3 to 1 by doing this. I started out with 7 objects. I arranged 4 of them. So out of that 7, I subtracted out the 4 that I'd already used, and that left me with 3, 2, 1. So there's the 3, 2, 1. So I'm going to write this now like this. 7 minus the 4 that we'd already taken out, factorial. Let's make a general statement here. Suppose you start with n objects and you're going to arrange r of them. Now these are just letters. For example, in our little problem over here, n was 7, right? Out of 7 objects, out of 7 people, we were going to arrange r, 4 of them, right? So n is the number of objects you got, r is the number that you're going to put into some kind of an order. Now a notation for doing so is this. We use the capital P for permutation, then parentheses, and then n, comma, r. And you read that as a permutation or an arrangement of n objects taken r at a time. And from our work below, I have an idea of how this works, right? It's going to be this. I'll write it up here and let's match it up. It's going to be n factorial. Now I'll do it for r's down here. What did we have? 7 objects, 3 at a time. And what did we get? We get 7 factorial. So that's what? That's the total number of objects that you start with. We started with 7. So up here I'm starting with an n. And then what did you get for the denominator? Look what we got over here. 7 minus 4. So 7 is the number that you start with minus the number that you arrange. So for us, up here, right, so down here, I'll just go down here kind of fast. This was what? 7 minus 4 factorial. So for us, if I bring that up here, I've got n objects, and I'm going to subtract out r of them to arrange. So this is going to be n minus r factorial. There's the formula that we're looking for. So a permutation of n objects taken r at a time is n factorial over n minus r factorial. So here's an example. What if you have, say, 8 objects and you want to arrange 3 of them? Right, by formula, it's going to be 8 factorial over 8 minus 3 factorial. And now actually we can do some of this by hand. I'll get 8 factorial over what? 5 factorial? Now here's a nice little trick. This 8 factorial up here, I'm going to rewrite it. I'm going to stretch it out until I get to that bottom 5. The top number will always be bigger than the bottom. So I'm going to write it like this. 8 times 7 times 6 times, and then 5, what? 5, 4, 3, 2, 1? That's 5 factorial. And the bottom, you've got a 5 factorial. And then what do you notice? 5 factorials cancel, and you're left with 8 times 7 times 6, which is 336. Now, if you've got a TI-84, you can do this in this way. Type in an 8, then press the math key. Now, the math key is in the very leftmost column, about the 3rd or 4th button down, depending how you read it. So type in 8, press the math key, and then arrow over until you get to PRB. It's the rightmost menu item. So 8, type in 8, press the math key, arrow over to PRB. You get a menu, and I think it's the 3rd one. No, it's the 2nd one. It's the 2nd one down. You get PRB. You get NPR, right? N objects arranged R at a time. So select that one. You can either scroll down to number 2 and press enter, or just press the numerical key 2. That one pops up. Then type in the number 3. So what you're looking at now is this. 8 NPR 3. And then you press the enter key. Look at this example here. Suppose you have 7 objects and you're going to arrange just one of them, right? So just intuitively, if you got 7 things, how many ways can you choose one out and arrange it? Well, if you did it by the old method, what would we have? Out of 1, I could put any one of those 7 objects there. So I'm thinking intuitively this should be a 7, but let's verify it by formula. So the number of permutations of 7 objects, one at a time, is, all right, it's the 7, the total number that you have, factorial, over the difference, the first minus the second. 7 minus 1 factorial. So you get 7 factorial over 6 factorial. Now, break that 7 down until you get to the 6. Doesn't go very far, right? What do you get? 7 times, and then 6, 5, 4, 3, 2, 1. That's 6 factorial. Over the 6 factorial. The 6 factorials cancel, and we are left with, let me get the same color there, we are left with 7. What if you did this one here? What if you had 7 objects? How many ways can you arrange all 7? Well, what is this? 1, 2, 3, 4, 5, 6, 7. So if I use the multiplication principle, going left to right, I could pick any one of the 7 objects, put it here. Then I'd have 6 left, any one of those 6 here. 5 left, any one of those 5. Then 4, 3, 2, 1. That turns out to be 7 factorial. So I'm thinking this one here should just be 7 factorial. Let's verify it by our formula. Permutations of 7 objects, 7 at a time, is, start off with the total number of objects that you have, that's your numerator, factorial, over the first minus the second. That becomes 7 minus 7 factorial, which is 7 factorial over 0 factorial. Now, do you remember this one here? 0 factorial, by definition, is equal to 1. So that's 7 factorial over 1, which is 7 factorial, just as we expected.